Voyager 1 is in interstellar space, and it's taken a lot of work from brilliant engineers at NASA's Jet Propulsion Laboratory to get it there. But a recent engine problem threatened to forever cut off the beloved spacecraft's communication with Earth. Let's dive into how engineers diagnosed and fixed Voyager 1 from 15 billion miles away. I'm Swapna Krishna, and today on Astra, we're going to talk about fixing Voyager 1 again. You may recall that there was a long period of time from late 2023 to mid-2024 where Voyager 1 was having a computer problem. It was basically sending back garbage data to Earth, and we didn't know whether it could be fixed. But engineers pulled it off. I have a full deep dive into what exactly happened during that time period and how NASA fixed it, so check out that video if you're interested. But what we're going to talk about today is a different issue. Voyager 1 has been having thruster problems, and they've built up into a very serious concern. The spacecraft isn't using thrusters to propel itself through space. That's happening just based on momentum. But in order to communicate with Earth, Voyager 1 needs to keep itself pointed towards our planet, and for that, it needs functional thrusters. Engineers thought that they could fix the problem, but there was a question of whether implementing that fix would further damage the spacecraft. Here is how they managed it. Voyager 1 launched on September 5, 1977. Its original mission was to fly by Jupiter, Saturn, and Saturn's largest moon, Titan. It was the first spacecraft to enter interstellar space on August 25, 2012, and since then, it's just been a game of prioritization to keep the spacecraft operational and in communication with Earth as long as possible. The problem here is the thrusters. Basically, when engineers were designing Voyager 1 and 2, the two spacecraft, both currently outside our solar system, are identical. They chose hydrazine as the propellant for a simple reason. It's very easy and very reliable. The probe has 16 hydrazine thrusters, and a healthy Voyager 1 spacecraft would conduct about 40 thruster pulses per day to keep its antenna pointed in the direction of Earth. But sadly, Voyager 1 is not a healthy spacecraft. The side effects of these constant thruster pulses have been building, and over the years, the fuel tubes inside the thrusters have become clogged. These aren't the tubes that provide propellant to the thrusters. They are the ones that direct fuel to the catalyst beds, where it's then turned into a gas. What this means is that more fuel is required to do the same amount of work pointing the spacecraft with each of those pulses. Voyager 1's fuel supply is not endless. They don't want to be using more fuel than they need to, nor do they want the tubes to get so clogged that the team can no longer fire the thrusters. Right now, the twin Voyager spacecraft have about a decade of fuel left. If it weren't for the computer issue last year and early this year, this hydrazine thruster problem would have easily been labeled the most significant problem facing Voyager 1 over the past few years. Now, the team has been taking steps to mitigate this problem over the years. The Voyager 1 team first noticed the problem in 2002 with one branch of attitude control thrusters, and they just switched to the other one. The spacecraft has 3 different branches of thrusters. The attitude control thrusters take up 2 of these branches, and then one is the trajectory correction maneuver, or TCM thrusters. The TCM thrusters are identical to the attitude control thrusters, they're just located on the back of the spacecraft. But as I mentioned, Voyager 1 isn't using its engines to correct its trajectory. That means that these TCM thrusters hadn't been used since the Saturn flyby on November 8, 1980. Well, on November 28th, 2017, for the first time in 37 years, engineers powered up the TCM thrusters. They worked, and so Voyager 1 switched to exclusively using these thrusters in January of 2018 and shut off the other thrusters. Well, now these thruster tubes are also clogged, and they're even worse than the attitude control thrusters were. These tubes were originally 0.25 millimeters in diameter. Now they're 0.035 millimeters, which, according to NASA, is about half the width of a human hair. So now they have to switch the thrusters back from the TCM thrusters to a branch of the attitude control thrusters. Simple, right? Well, when it's an almost 50-year-old spacecraft, 15 billion miles away from the Earth in interstellar space, nothing is simple. To understand why this is a problem, we need to discuss Voyager 1's dwindling power supply. Voyager 1 uses 3 radioisotope thermoelectric generators, or RTGs, for power. You can think of this as functionally nuclear batteries. As the plutonium decays, that's converted into electricity. But because it's limited by the half-life of the fuel source, in this case plutonium, basically these RTGs produce less and less power each year. Voyager 1's available power decreases by around 4 watts per year. That's why engineers have slowly been turning off science instruments and conserving as much power as possible, because the spacecraft has to operate on less and less power each year. One of the results of this is a loss of heat. Basically, between shutting off science instruments that generated heat and shutting off heaters of thruster branches they weren't using, the spacecraft is cold. It's too far away to be warmed up by the heat of the sun. Because of this chill, engineers couldn't just flip a switch and turn on the attitude-controlled thrusters due to the risk of damage. They needed to turn on the heaters first for these thrusters, and that's the problem. Where's the power for that? At this point, any extra power use on Voyager 1 has to come at the expense of something else. And they didn't want to just turn off a science instrument in order to power the heaters for a while, because what if they couldn't turn them back on? And the problem is also, there's no real way to test this on the ground. According to NASA, there are no functional models or test beds of Voyager hardware or software anymore. And on top of that, even if there were, there's no way to simulate the conditions that the attitude-controlled thrusters have been in these last few years, nor the conditions that the spacecraft has been in for the last 47 years. Engineers have actually used Voyager 2 as a test bed for Voyager 1 previously. Because Voyager 1 is further out into interstellar space, it's considered more valuable, basically, at 15 billion miles away. Voyager 2 is around 12 billion miles away. Back in 2023, engineers sent a software patch to the Voyager spacecraft, but they sent it to Voyager 2 first. That way, they would know if the software rewrite would work before sending it on to Voyager 1. In this case, though, they had to work directly with Voyager 1 and make sure they got it right on the first try. So they had to come up with another plan, and one that wouldn't risk damaging the spacecraft's thrusters or its instruments. In the end, engineers determined that it would be safe to turn off one of the spacecraft's main heaters for up to an hour, which would allow enough power to flip on the thruster heaters. But keep in mind that it takes 22.5 hours one way for a command to reach Voyager 1 through the Deep Space Network. That means that the team had to send the command to turn off the main heater, send the command to turn on the thruster heater, then after a delay, but not more than an hour, send the command to turn on the thrusters, then send the command to turn off the thruster heaters, and then finally send a command to turn the main heater back on, and then just hope that it worked, because it would take another 22.5 hours, total round-trip communication time of 45 hours to see if any of this worked. Well, the sigh of relief. For the first time in 6 years, on August 27th, that branch of attitude control thrusters pointed Voyager back at Earth. The thruster switch was successful. It's great news, but there's a good question that comes out of all of this. How long can the team keep this spacecraft going? Voyager 1 was designed for a 5-year mission, and yet here it is, 47 years later, still going. Currently, Voyager 1 has 4 operational science instruments: the plasma wave subsystem, the magnetometer instrument, the cosmic ray subsystem, and the low-energy charged particle instrument. 6 additional instruments were either turned off after the Saturn flyby or have been switched off due to dwindling power. As I mentioned, Voyager 1 has about 10, maybe 15 years of fuel left. But really, engineers are just hoping to keep the spacecraft operational through its 50th anniversary in 2027. Current estimates are that it will continue sending back science data through at least 2025. The hope was that with the switch to the TCM thrusters, they'd buy another 3 to 5 years for the spacecraft. But now we're back to using the still clogged attitude control thrusters. And it's not clear how long they will be able to continue to point Voyager towards the Earth. If Voyager can still point itself towards the Earth, it will continue to send back engineering data as long as it can, through 2036. Science instruments will have been shut off well before then, but 2036 is the point that Voyager 1 will travel beyond the range of the Deep Space Network, and it will no longer be able to communicate with the Earth, even if it still has power and the ability to keep itself pointed at the Earth. For now, I'm just really glad to see this spacecraft is still operational. It's hard not to get attached to various spacecraft, and Voyager 1 is one that I am very personally attached to, and I know I'm not alone. So I'm glad we're not having to say goodbye yet, even though I do know it's coming soon. But for now, that's about all I have to tell you about Voyager 1. Thank you for watching. I am Swapna Krishna, and this is Ad Astra.